Okay, good afternoon, everyone, once again. Uh, Today we are going to look at what we call multimodal models. These are models that can do more than just one form of medium. Like, for example, um, they can do audio, speech, they can do images, right? In addition to the text, conversational text that we have been looking at. So we are going to see how we would be able to utilize the capabilities of these multimodal LLMs in order to, basically achieve our objectives, right? As developers. As developers, we want to see how we can bring intelligence into our applications, into our tools, into all the things that we build. And multimodal is not an exception, right? So let's start. So we are going to look at, for today, we're going to look at speech. Um, then on Friday, we're going to look at image. So for speech, we have what we call speech to text, right? And you see a couple of models that specialize in speech to text. Whisper being one of the most popular ones. But we also have other ones. We have Assembly AI, and then we have text to speech. Text to speech is so the other word for speech to text is speech recognition. In other words, it recognizes the speech and turns it into a text stream, right? Then text to speech is the opposite of it. We take a text stream and we transform it into speech, and that is called speech synthesis, right? So any of those terminologies can be used. But in addition to doing speech to text and text to speech, you also have to think about what we call audio capture, being able to capture the audio in the first place. So if you are using a front end framework, right, how do you capture the audio? If you're using a back end framework, how do you capture the audio? And then also, how do you, after the speech synthesis, how do you share the resulting audio or audio file back to the user or the client? So we're going to look at some of those things. Then we'll talk about how we can build an AI-powered meeting notes generator. So basically, this is kind of a speech to text and then text summarization tool. So first of all, of course, in meetings, it's going to be speech, like what we are doing currently. So the meeting notes generator is going to take all the speech, run it as a stream, right, and pass it through any of these speech models that will generate text. Then the text can then be channeled to an LLM that will take that whole text, or we can first of all compile it and then send it to an LLM that will do a summarization or generate action items and all those kind of stuff. So then on Friday, we're going to look at image generation. So we have a bunch of models that are really good at that. DALL-E was one of the first ones. Then we have Stable Diffusion, Midjourney, and so many others. Then we have image recognition APIs. So like Google Vision, AWS Recognition. These are APIs in the cloud that you can send images to and give them various prompts like, caption this image or identify who is here and identify, the number of people and those kind of things, right? Then we'll also do a little bit on OCR, which is optical character recognition, and then visual data extraction. OCR is handwritten notes or typed out scanned documents that were printed which you want to extract the actual words and sentences from them. And then you maybe either store it or document it for some reason. Then combining text, image, and audio models. So we are going to look at basically when we hear multimodal, that's you have to be able to combine all of that. I haven't mentioned video here, by the way, because well, there are a lot of really interesting video technologies these days. So We'll look at some of those. Okay, so first of all, like I said, today we're going to talk about speech to text and text to speech. So speech to text. So what's speech to text? Speech to text basically is converting the spoken word into accurate structured text, right? Using neural network models, like Whisper or Assembly AI. These are just two of the examples. There are more of them, right? So that's what speech to text is basically. Then text to speech is generating natural sounding human-like speech, audio from written text using again neural TTS. TTS means text to speech system. So neural networks that have been trained to be able to generate audio output that really just sounds like the human voice. Now, this for me has always been a very interesting topic, especially for me as an African, because there is a certain amount of bias in this whole speech to text, text to speech thing, right? You have a situation where we have a lot of corpus of data, recorded voices and all of that that are in accents and languages that are not African. And this body of data is what is used to train a lot of models. So you find a lot of models, including things like Siri, Alexa, and so on, they find it difficult to understand the African intonation, the African accent, and the way we speak. So there is a limitation there, and I can tell you there is definitely a lot of opportunities there. But well, as it turns out, that is something that machine learning, engineers would be able to do. Take a model, gather the corpus of African voice data, and use it to fine tune already existing speech models like Whisper and so on, so that they can be better able, basically improve or increase the amount of data they're trained on, so that they become better, at doing all of that stuff. So anyway, that's what speech to text, text to speech is. So what are the other things that we will discuss in today's session? We have what we call audio classification. So audio classification is basically kind of um, identifying content and labeling content, that comes from audio. Identify and label content that comes from audio, right? And this is very useful because sometimes you may want to, if there's a conversation, you may want to know, okay, this meeting, for example, if it's a meeting, um, what are the action items? What kind of, was there music in that? Was there speech? What was the sentiment? How were people sounding? You know, so those are some of the interesting things that you want to be able to do, right? You want to be able to do that when you are when you send an audio clip to an LLM. Okay, so that's audio classification. Then we also have real-time AI workflows. This is a more challenging kind of task because real-time AI workflow means basically you have um, data that is flowing in real time, like in meetings, in conversations, in a whole bunch of other things, right? And as it is happening, you want to keep capturing it, and you want to keep either transcribing it or something, right? So if there is latency in your application or in your model, if it is slow, it may miss some things or drop some things, So you always want a situation where it should be able to pick up and match the pace or the speed at which the conversation is going on, or at which the sound is coming in or is being generated. And so being able to do all of that, this being able to do speech recognition, being able to do this analysis, being able to do audio classification, you know, so you need pipelines that will operate instantly on streaming audio. As the audio is coming in, it is doing the recognition and transcription and maybe even, summarization immediately, right? Without any latency. Otherwise, it will end up losing data. So at the end of the day, we'll also see how we can do a simple hands-on project where everyone can learn how to build a transcription and summarization system that will convert meeting audio into structured notes and action items. So let's start off by trying to understand what a multimodal model is. These are basically models that accept more than one data type. So they can accept text, audio, image, or video, right? Then that allows them to be able to do what we call cross-modal task, right? So cross-modal tasks are tasks that you can ask in one data type and expect the response in a different data type or form. So for example, you can send speech, yes, and it converts it to text. That is cross-modal task. You can also send text and you expect it to translate to speech. That's also cross-modal. You can ask it to extract meaning from audio. You can, give it an image, for example, scan an image and you upload it and you tell it to tell you what is inside that image or to read the text or to write out the text that's inside that image. In fact, really serious multimodal models would be, I can actually scan an image that contains a sign, for example, or some text, for example. So it's an image, it's not actually text that I type, but it's an image that I scanned. I upload it and it can speak, give me a speech, output, audio output that contains the words that were captured in that image. So that's another example. In this case, text is not even in it, it's from image to audio. So that's the beauty of multimodal models. Um, it allows you to basically do cross-modal tasks very easily. So in the context of speech, right, these are some of the examples. So Whisper, like we said already, OpenAI also has TTS. Then Google Gemini is multimodal. Then OpenAI Chat GPT 4.1 audio, right? Then Azure Speech. And there are a bunch of others as well. So it's not yeah, it's not I think this is not an exhaustive list. There's a whole bunch of other ones that you can look at. So why does audio matter, in AI systems? So like I said, human beings generally, most of our interactions are speech, right? Yes, these days we type a lot of text, of course, as well with our social media accounts and so on. But a lot of conversation still happens as speech. And it's always easier. You can do speech hands-free. You can talk while driving, for example, but you cannot be typing a chat while driving. So for me, one of the interesting use cases, and I might even use this opportunity of this program to build one, is an assistant that I can there are times when I'm driving and I just remember something I needed to do that I know that once I don't write down, I'll forget. In fact, it has gone to a point, at some point, I will even park the car at some point and write it down. But imagine if I had a voice assistant, I could just give it an instruction, take note of this thing for me. And it doesn't need to record it as a voice note, right? But just transcribe it into the words and maybe send it to me as an email or store it in my to-do list or something, right? So things like that, those kind of voice interfaces, either voice assistants, call centers, support bots, reminders and so on. That's one. Then secondly, accessibility. Accessibility basically refers to um, an area in software development, specifically web-based software development, but generally software development, where you want to cater to people who have limited in terms of um, how do I put it? Capabilities, right? Perception or perceptual capabilities. So like either people who are either blind or people who are deaf or people who are one limitation or the other, right? So you always try to ensure that your design, you include such people in your design. You bring in features that allow them to still interact normally and naturally with your application. So when you look at screen readers as an example, that's for blind people. So screen readers read web pages or websites to people who cannot read. And you have reading assistants. And then you even have situations like people who are deaf, they cannot hear, right? So you may want something that can transcribe speech into a written form so that they can view it. So there are so many different things that audio would allow to do in the context of accessibility. Then, of course, business insights as well. So meeting transcription, analytics, um, if you have an AI that actually does transcription of meeting notes, I can assure you it will be probably more efficient than a human being. Human beings may sometimes miss. I know when I was a secretary, sometimes I'll miss a couple of things. But with an audio AI system, you capture everything. Automation, yes. So audio classification, tagging, compliance, right? So there are examples from Zoom AI Companion, Otter AI, Assembly AI. You can even look at, like currently as we are now, there is actually a Zoom AI Companion that has been activated and is taking notes on this call. So you can build one for your own software as well. So that's why this is very important. So let's break it down a little bit more. So speech to text, yes, technology that converts spoken language into written text. It uses automated speech recognition, ASR, to capture audio, convert it to a digital format, and then use algorithms to translate the sounds into words and sentences. So this process is also known as voice recognition, voice to text or dictation. It's used for applications like dictation, creating video captions, and for accessibility purposes, what we've just said. So it converts raw audio into text. Now, there are three core components in a speech to text model, right? The first one is the acoustic model. So the acoustic model is going to take your sound and break it into what we call phonemes. So a phoneme is kind of a unit of sound. It's a unit of sound. Um, you can't just take just like we have word embeddings for the words. For sounds, we have the phonemes. And the phonemes, for any two sounds that sound alike, they should have exactly the same phonemes. Phonemes are not they were not created by, natural language processing or speech. These are things that already existed in phonetics, right? So you can go and check what a phoneme means, right? Um, but it's basically is the smallest unit of sound in any language, right? That distinguishes one word from another. So if if two sounds that sound alike will have the same phoneme, and if two sounds don't sound alike, they can't have the same phoneme. Okay. Um, then that's the first part. So you have an acoustic model. That model will take the sound that comes in. And remember, this sound comes in as an audio file. An audio file is basically a recording of bits and bytes. If you break it down that way, in fact, a lot of models they can work on that the bits and bytes that are encoding of sound. But if you go and study encoding of sound, you see that there's a whole lot of algorithms there as well, right? First of all, you have the sound wave, which is an analog signal. That analog signal is then converted to using ADC, analog to digital converter. It's converted to a digital stream of binary numbers, basically, or floating point numbers. Same kind of thing, right? And then it's compressed and stored, right? So, but in the old days, there were times when you could say, okay, let's train a neural network to just listen to those compressed versions. But I don't think that's a very good approach because that's not the natural representation of the sound that's coming out. So instead, models are now trained on the natural sound. It has to first be encoded into digital numbers, right? Binary numbers, basically. And then you now have the acoustic model that will take those binary numbers and you train it and it encode them to the phonemes. Then the phonemes now you now put them in a language model. So the language model takes the phonemes, which is again a stream of things that represent sounds, and then it comes up with words, right? It comes up with words. And then the last bit is the decoder. The decoder will now take those words and then work out the best sequence of those words that matches what was spoken. So that's basically the stack of it. So some of the challenges that you have in speech to text, one, the accent. So I just talked about that, right? So yes, speech to text is a really difficult thing because the data um is not as clean as text to speech. Text to speech, you just have text, right? So you can generate the sound that matches each of those words or the sentences. But speech to text, five different people can pronounce the same word in five different ways, right? And that's where all of these models become really good at it. They are able to extract the real meaning in spite of all the variations. But then there are some variations that are so far away, like outliers, that they are so far away from the common one data set that you are trained on, it still is not able to place it, right? So accents form those kinds of variations. And in every case, whenever it comes to neural networks, right? Training with more data is always the best solution. So if there are accents, they ultimately the ideal solution would have been collect voice data of all the different accents and train the model on it, and the model will still eventually learn how to understand. It basically it's the same thing as a normal human being. There are some accents you will listen to you've never heard of. You've never heard such accents before, so you not understand what is said. But when you keep speaking to people with such accent for a long time or for a while, you begin to understand what they say. Your brain has learned, to separate the noise from the signal, right? And it has learned to be able to extract the message. Same thing, with the neural networks. So that's one. Then the second kind of challenge would be background noise. Background noise is always going to be a problem, especially considering that most times you train these models on sound recordings that have no noise in the background. So it does not learn, it never knows how to distinguish between the signal and the noise. Because it does not know, it will not be able to distinguish. So that's another thing. So of course, the solution to that is we'll have synthesized data that contains some artificial background noise or even natural ones that you record, and you record a lot of background noise along with the speech, right? So um, eventually the system learns to do that. But sometimes background noise is so much that the model may not even be able to filter it. So you can use some kind of pre-filters, some kind of noise reduction systems, or noise cancellation systems in order to reduce background noise. Then there is domain-specific terminology. So again, this has to do with terminology that is specific to a particular domain, maybe a particular tech technical area, right, which the model wasn't trained on. So it still boils down to the model does not have, as much data as it should, or it doesn't have data in that particular regard. So it is not going to be able to do a good job on that. So those are things for you to take very good care and very take note of when you are building your systems. That those are things that will come up in the real world. And how do you handle this? Okay, so let's talk about one of the open source speech to text models. That's Whisper, right? So Whisper is trained on 680,000 plus hours of multilingual audio. So that means it's trained on audio from multiple different languages. So what does that even tell you? That Whisper can actually do language translation as well, because it is trained on data from different languages. It can not only just do language translation, it can even translate in, speech. It can generate speech in multiple languages. So you can actually use Whisper to do a kind of say, translate what I'm saying to this other person's language and say it to him, kind of application app. I always wanted to do that. In fact, there's an app. There's a time when I was much younger, I wanted to do apps that if somebody calls me on my phone, I can choose which language, if the person is speaking a different language, I can choose to hear what the person is speaking in English or any other language. So Whisper can help you do that. So some of the strengths of Whisper, robust to noise, is accurate on a lot of languages, and it handles accents very well as well. And it provides timestamps. So you can use Whisper for transcription, subtitles, meeting notes. By the way, Whisper is an open source model, which means that you can actually download it and run it inference with it on your computer. But Whisper, of course, requires a lot of compute because it's a big, it has a lot of parameters. So you probably need a GPU type of thing to be able to run that. And we may actually do a bit of hands-on where I don't know how we can, if you have a strong laptop that, can run Whisper. But even if we can't, we can take a lightweight, smaller number of parameters version of Whisper. It's not as good as the ones with, is it 100 billion parameters or so, if I can remember. Um, so it won't be as good as those ones, right? But at least it can give you an idea of what you can do. Okay. So the other thing with Whisper is that um, if you look at the trade-offs, okay, it's 1.5 billion parameters. If you look at the trade-offs, you see that um, it has multiple different sizes, like I just mentioned. It has a tiny one. It has the base Whisper, right? It has a small Whisper. It has a medium Whisper, and it has a large Whisper. So the tiny Whisper has about 39 million parameters, right? So those 39 million parameters are pretty good, but they are not enough to do a really good job on some kind of task. So you'll find that if you use those ones, yeah, it will do well, but then you may find yourself in a situation where it's not giving you um, very good output, right? So that's Tiny Whisper. Then you also have Whisper um, that is base, right? The base size. So the base size of Whisper, that one has 74 million parameters, right? That's about the same size, or that's about twice the size of the Tiny Whisper. So that one that has about 74 million parameters, it does better, right? It does better. But you still want to go to the one that the small, which is bigger than base. It has 244 million parameters. And it's also, all of them are multilingual, by the way. So you can run a bunch of stuff on it. Then you have medium. Medium has 769 million parameters. Then you have large versions 1, 2, 3, and large has 1.55 billion parameters. Then you have turbo. Turbo is the super, um, it has 809 million parameters. So if you could get large, you get full, capability, but you need really strong GPUs to be able to run Whisper with 1.55 billion parameters. So, but what I would encourage is you could try any of these ones, even the tiny one, right? Which you can run on your computer, even on a CPU, and see what Whisper does with that. So we'll see if we can do a bit of hands-on with that. Even though for today we are going to call out to the API, right? So the trade-off, of course, is that the smaller ones will be faster and require less memory. So you can actually use them in real-time applications. For example, in edge devices, if you want to deploy them on phones, on phone apps and all this kind of stuff, they're not that much, they're not big. If you look at it, the size of the English only variant for tiny is about 39 megabytes. So it's something you can even bundle into an app, right? But it won't be that good, okay? Um, the trade-off, but the you can if you want really good accuracy in transcription and all of that, you have to go for larger ones, including the small, medium, and large. And for those ones, of course, you can't run them on edge devices, so you have to run them on your server, which should have a lot of GPUs, and you can then call out to the API. You can build APIs around them. So that's Whisper. Okay, so how do you use Whisper? You can use Whisper via the OpenAI transcription API, right? So we're going to do a bit of this, right? Um, you will have to open an audio file. So you have to have an audio file that you have recorded and you upload, right? And then typically like an MP3 file. So when you open the file, you uh, just send that audio file in its raw form, raw MP3 file. Send it to Whisper. That's all. You send it to that endpoint, and you specify, and then you see what it gives you back. And that's typically how you do it. You use the client audio transcriptions create function in the OpenAI client. Specify the model, you pass in the file. If you can also specify the response format. So either you can, if you want the verbose JSON format, if not, it will give you straight up text, right? And you see how it looks like. So we are going to try this in a second to see how we do Whisper. So after Whisper, we also have Assembly AI. So Assembly AI is kind of dedicated production grade audio platform, right? So just like Whisper, it has speech to text, right? It has summarization, so it can summarize your, you know, the content of your audio file. It can do sentiment analysis of the content of the audio file. It can also do audio classification. It can do topic detection, and it can do toxicity detection. It can do speaker diarization, right? So, but Assembly AI is API driven. So it has an API you just call and you can send the MP3 file, to it. So again, this is just an example with a Python. The same thing, most of these will also have the equivalent in JavaScript and in other languages. So you can just check their website for check on the developer documentation. You see how you can call those APIs from either JavaScript or Dart or Golang. So you just call this, AI.transcriber, and then you pass the name of the file. So in this case, you pass the name of the file. This transcriber.transcribe is going to upload the file automatically back to the API endpoint and send that audio file into the transcriber, which will transcribe and give you the text. So that is how you use Assembly AI. So if you compare the two of them, you find that with Whisper, you can either self-host it or you can call it on OpenAI. I believe there are other platforms that allow that host Whisper, because Whisper is basically an open source. It's a free model, right? Um, so maybe you can even check Hugging Face. I'd like to check Hugging Face um, for that. Um, then, but for Assembly AI, right, it's fully managed. So you can't download their model. You basically send your audio recordings there and it does whatever you ask it to do. So in terms of accuracy, Whisper is high, Assembly AI is very high, according to this assessment. Then the extra features, Assembly AI has many additional features, sentiment, topics, profanity, and so on. Whisper is minimal. For Whisper, most of these kind of things, you would basically have to chain it, right, in a pipeline. So you first of all just do text transcription. Then you can take that text and still send it to another large language model and ask it to do whatever else you want, including sentiment analysis and all of that. So when you're using Whisper, most of the time you are going to use Whisper as the first stage in a pipeline of what you are going to do, right? Whisper will not really do everything for you. Assembly AI, you can just tell it what to do and it does all of that. For Whisper, you have limited streaming, Assembly AI, full streaming. So Whisper is best for custom and offline applications, while Assembly AI is best for production pipeline. So you can use Whisper to experiment and try out all your stuff. And then when you are done, when you want to deploy, you can then decide, okay, I'll go to Assembly AI and use that, to provide the service to you. Okay, so I would like to try a few things before we move to the next one, which is text to speech. So let's see. Before I go there, are there any questions? So I'm going to look for an audio file and I am going to, I'll just do a collab. Okay, so the first thing I want to do is I will first of all just I'll pull in the I want to use a whisper to make it faster. I'll see if I can get, well, I'll try with OpenAI first, but I don't think OpenAI is going to give me whisper on their AI without a payment being made. So if that doesn't work, then what I will do is go to Hugging Face because Hugging Face also hosts Whisper, right? And see if I can access Whisper, you know, from Hugging Face. So let's go. So of course the first thing is to import our OpenAI um speech 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 to text. So let's import from OpenAI import client. Okay. So I just I'll just do a quick um create the client. Okay. So we just do open there. Okay. Okay. So I need to get an audio file and upload. That's the first thing I need to do. Okay, let's see. I think I have a couple of audio files here. MP3. Uh,
Friday, September 26, 2025. Good morning and welcome to XL News 360. Here are stories and events making the rounds at this time. STEM schools are back and 6-week holiday tech camp advises on practical ICT. We'll get you details of these in a moment. Thanks for joining us. And now the news. Parent, teachers, and policymakers in Nigeria's education sector been advised to prioritize practical information and communication technology (ICT) knowledge during accuracy. You're listening to the news live. Excel FM. It's Friday, September.
okay, so I was looking for an MP3 file. I'll stop sharing my screen and reshare with audio just so that you can hear the sound. And I want to see how good Whisper is going to do this. It's a pretty long file. So let's see. I'm going to share my sound now. Okay, so give me a thumbs up when you hear this. This is just, I hope the sound comes through.
Listening to the news live on Excel FM.
Can you hear the sound? Give me a thumbs up.
It's Friday, September 26, 2025. Good morning and welcome to XL News 360.
Okay, so at least we got the sound, right? And we have heard the first few lines of it. Now I'm going to upload that into this, into here. So let me upload that now. Okay. So it's a 3 MB file. It's 3 MB. Let me just call it audio. Let me rename it to audio. Okay. So, of course, I have to set up my OpenAI key. So let me do a .m file as usual. I'm going to import, um, yeah, so I'm going to do that. I would put the API key here as well when I'm creating the client. API key. Okay. And then I am going to upload my API key. Let me just upload all the API keys. Okay. All right. So then let me rerun this. I'll likely get a pushback from OpenAI, but maybe it might be different in Whisper. But OpenAI doesn't run models for free. Even if the model itself is free, their software platform, their compute platform rather, is not free. So it doesn't let me do that. So let's try Hugging Face. Hugging Face. So Hugging Face has speech. By the way, there are a bunch of others that have speech models as well, right? So I just go to their models page and I can even, you can see text generation any to any. So any to any is more like multimodal. Image text to text, image to text, image to image. So you can see text to video and text to speech. I am looking for speech to text though. So let's see. We have text to speech, but we don't have speech to text. Let me look for speech to text. So we have automatic speech recognition, which is the same thing as speech to text. And you see there's a whole bunch of them. So here is OpenAI Whisper Large version 3. Whisper Large. So remember we said Whisper has a whole bunch of different sizes, right? And if you remember, Whisper Large is the biggest of them with about 1.55 rather, 1.55 billion parameters. So this is really huge. I will try this, right? If not, I'll go for a smaller version of Whisper because you have Whisper Large V3 Turbo. It's 4.57. Um, I don't know if this is megabytes, right? Or if this is million parameters. And then you have Whisper Large 3, 4.89 million. Um, this should be this should be this. Oh, sorry, this is the number of downloads. So that's the number of download. It has nothing to do with the size of the model. This is the size of model. This is 2 billion parameters, 1.55. So this is the turbo, which we saw here. The turbo is about 809 million parameters, which you can see 0.8 billion. That's 800, about 800 million parameters. So there should be a bunch of other Whisper. There's Whisper Small, 0.2 billion, which is 200 million parameters, right? That's this 244. So let's start with Whisper Large, right? And see if this is available. So I'm going to go with Hugging Face. So how to use Hugging Face? This is example of how you do this, right? Um, this is for fine tuning. I don't know if we can just use regular the regular API to call this because we have to use their API. So let's see. I'm going to pull out the code to call this. Let's try Open Router. So Open Router, input modalities, text. We want speech to text. So we need audio as the input modality, and we need text as the output modality. So that will give us speech to text. So let's see if we can find Whisper here. We could also search here. Okay, so Open Router doesn't have Whisper. Well, we could also try Gemini. We have OpenAI GPT 4.0 audio. So let's see if we can use Gemini, or let me see if I can pull the get the code to do this. I can't just use this. Okay, so we can't just pull it directly according to we will have to pull it locally and run it using PyTorch. Okay. Yes. So for Hugging Face, we use Inference Client. I had forgotten that. Okay, so we will not use Open Client this time. We use Hugging Face's Inference Client. So to use Inference Client, you will first of all import Hugging Face Hub. From Hugging Face Hub, we import Inference Client. So we will use that. Of course, this is Hugging Face. I already have my Hugging Face API key. Then we specify the model. So, hold on. Okay, clients. Then, whether equals auto API key os dot environ. Yep. Get Hugging Face token. I think that's what I called it. So we create a client, a Hugging Face inference client. Let me just confirm that I have it. Okay, so here I call it HF API key. HF API key. All right. Then we can now load and do do the actual voice client dot automatic. So for Hugging Face, they call it automatic speech recognition. And we specify the model. So the model we want to use is not Facebook. Well, okay. AI is suggesting Facebook for me. That's nice. I'll just check it out later on. But we want to do Whisper, and I hope it is available. So we copy this OpenAI Whisper, OpenAI Whisper Large version 3. And that's the model. And then let me check this. The audio should come first according to the documentation. Audio, which is the MP3 file, open it for binary reading, and then we specify the model. Okay. So that will run it, stream back the response to me. Let's see how well this goes. I can now print the result. I prefer to use display, and we'll see how it looks like. Okay, so let's run this. All right, so let's look at this inference client. You only need to specify provider and the model. Okay, so we could actually have created this by specifying the model up here. Let's run it again. Oh, there. I don't need this model anymore because I have already specified it when I was creating the client. Oh, and this should be model. Yep. Sambanova. Okay, so I should have actually specified the provider. So let's do that again this way. It's giving me two different ways of doing the same thing. So provider is auto. API key is OS. Hugging Face API key. So this should be HF. Okay. Let me just confirm again. HF API key. Okay. So I think I did a typo here by using providers instead of provider. I'll still specify the model at the point of inference rather than at the point of creating the client. And provider should be auto. Okay. So the provider it needs a different provider. Let me find the providers that are available. So of course we can easily just use Gemini for this, right? Um, this okay, so OpenAI is not providing this either. So it does look like we may have to call direct. So the other thing is we could load Whisper into locally and run it. I'll do that, but let me do a call with Gemini then. So for Gemini, we can import Google Generative AI as Gen AI. Okay, sorry, Google dot rather. Okay, okay, conversational. So we'll create the client. First of all, we'll do Gen AI dot key API key configure API key. Right, so I have this already. Gen AI configure API key equals Google API key. I think I called it Gemini API key. Yep. Let me confirm that. Gemini API key, right. So we configure Gen AI. Then we initialize the model as usual. Gen AI dot generative model. We can use Gemini 2.5 Flash. That one is still available. Then we can upload the audio file. So interestingly, Gemini gives us a way to upload audio file. So you just use gen AI.upload file, right? And you can specify the path and specify the file type according to the documentation here. But I'll just do path, right? Okay. Then, so we've uploaded the audio file to Gemini. And then, because Gemini is multimodal, what has actually happened is that we've uploaded a file to it, and then we can now give it a prompt dot generate. So this is typically how we call Gemini. You're going to send a prompt, and the prompt is going to be please transcribe this audio file, right? And then you pass the audio file instance that you got from calling the download. And then you can now print response. It will have the text. So you can see you are listening to the news live on Excel FM. So if you remember what I played, let me play it again. So now we can read along and see how good our text transcription was. Let me see how good it was.
Accurate.
You're listening to the news live on Excel FM.
Friday, September 26, 2025. Good morning and welcome to XL News 360. Here are stories and events making the rounds at this
Didn't
time.
get this one.
Esteemed schools are back and 6-week holiday tech camp advises on practical
Didn't get this one.
ICT knowledge. We'll get you details of these and more in a moment. Many thanks for joining us. And now the news in full. Parent, teachers, and policymakers in Nigeria's education sector have been advised to prioritize practical information and communication technology (ICT) knowledge for Nigerian children. The advice was handed down during the closing ceremony of Esteemed Schools Holiday Tech Camp held at Esteemed Schools.
Okay, so, well, I did notice a few errors in the transcription, especially still relating to this accent stuff, right? So I think the first one I saw was News Live. Okay, I think it was and it was ends and it was saying and. This was ends, but it transcribed this as and. Well, I don't know, maybe end is the correct way. So how would you say the END, the ends? I don't know. So this is I caught two. I can't remember the first one, what it was. I think it was for the 60. Yes, for the 60. Excel News for the 60. This wasn't correct. So anyway, so you see that that is um that is using Google Gemini. Now, let me try actually pulling Whisper into this um, Jupyter Notebook runtime, this collab runtime, and run it. Now, I may have to switch to a more powerful runtime. If I go to change runtime type, I may have to go use either a GPU or a TPU if they allow me, right? So let me see. Um, let me go for a T4 GPU. All right. So to use Whisper in this manner, this is now downloading it into the basically you're not calling an API because obviously I've seen that both Hugging Face and OpenAI are not allowing us to call directly into their API to access Whisper. So the only way we can access it is to download from their API and run the model locally. And I think there are several ways to do that. Um, if you don't have, if you have a paid OpenAI subscription, you can just call it directly. But if you don't, then we will have to do this ourselves. So let's see how we can do that. So you have to install a bunch of things. So this is going to be more of Python stuff. Um, so here, it actually is easy if you want to just run it. Um, you can just run it as a command, right? Or you can actually just run it as a command after you've installed it from pip. So let's see pip install. Run this as a command. Pip install open AI. Whisper. Okay, so Whisper is installed. Now, the interesting thing is when you install Whisper this way, you can actually run Whisper as a bash command, just Whisper. All right. I didn't provide anything, so it's not going to do anything, right? So I can now let me see where we are because I need to know where I am. CWT. I'm now going into kind of the CWD is okay. CWD PWT content. So PWT is to know which directory that I am currently in, and I am in the content directory, which is this directory right here. So there's no problem. Remember, if you note, I've lost everything because I switched runtime. Basically, runtime in Colab is a virtual machine that's allocated to you to use for that period, right? For that period when you're running that Colab. So because I switched it, I essentially switched to a different virtual machine. The one I was using where I had uploaded the .m files and everything has been disposed and wiped. So I'm now in a new one. So all of the stuff I had uploaded, it's all gone. So I have to re-upload. So let me re-upload that file. Okay. So I'm also going to rename it like I did last time to just audio. Okay, so we now we are in content, so we have content audio. So this tells me I am in the right place. So I can just do whisper audio.mp3, right? It's as simple as that, right? When you're running it as a command. So all of that, it is going to run it. And I think because I'm using a TPU, it's going to run a bit faster. I think I got a sorry, GPU, a T4 GPU. So it's going to run this really quick, as you can see. So that's you can see it has downloaded 1.51 gig. That's most likely the large model that it is going to use. So Whisper is a command that actually runs and is able to do stuff, right? So in this case now, it automatically downloads a model. The 1.51 gig model is most likely the 1.5 billion parameter model. I'm not sure, but I think so. After it has finished downloading, it then uses that model to run inference. And you can see it runs the inference. The interesting thing is that Whisper, as it's running the inference, is also giving you the timestamp in the audio file where it is getting all of that. So let's now compare what Whisper did with what Gemini did. So if you look at, remember Gemini started with accurate. You are listening to the news live on Excel FM. It's Friday, September 26, 2025. Good morning and welcome to Excel News for the 60. Now let's see what Whisper gave to me. Accurate. You are listening to the news live on Excel FM. Right, so that's okay. It's Friday, September 26, 2025. Good morning. Welcome to XL News 360. So Whisper gave me a better result. Welcome, good morning, and welcome to XL News 360. But Gemini told me, good morning and welcome to XL News for the 60, which is wrong. Okay, so let's continue. The second error I saw was, here are stories and events making the rounds at this time. Esteemed schools are back on 6 weekly. So that ends 6 weekly, 6 week holiday take camp. Now let's see what it esteem. So here Whisper gets it wrong. Esteem, Gemini got it right. Whisper is saying Astem, schools are back. Are back. Gemini got this one right. Are back and 6-week holiday. So for this particular paragraph, Whisper is even worse than Gemini. Okay, anyway, I'm not going to analyze the whole thing, but you can just try this out on your own and run Whisper and see what you can do with it. You can also run Whisper in Python, right? If you don't want to run it as a bash script, after having installed it as pip, you can still do an import Whisper, okay? Then after importing it, you can then run model equals whisper dot load model. So remember, you actually have to load a model. You can have base, you can have large, and so on. Let me just go with base. I want to know which of these. I don't know what it loaded here by default. Probably the base model as well. So if we did load the base model, then we won't need to download it again. We'll just load the one that it has already downloaded. So transcribe audio MP3, then I'm going to display the result. And let's see how this goes. So it has to download it, and you can see it's 139 million. So base is 139 million. Now base is much smaller than okay. So you can see here it gives you a whole lot of data. It gives you all the metadata, including apart from transcribing, yeah, so okay, it does do the transcription. You listening to the news live. So already you see that there are a lot more errors on the base. The smaller model is making a lot more errors already. This is saying you listening to the news live on Excel FM, while here it was saying you are listening to the news live on Excel FM. That's Friday. That's Friday, September 26, 2025. But here it's Friday, September 26, 2025. Good morning, welcome to Excel News 3060. So base is making a lot of errors already. Now let's try let's do this again, but I would use large. I'll use large instead of base. Oh, large is 2.8 gig. So what we did download the first time wasn't large. What we did download the first time was probably half of the size of large, meaning which one is half of the size of large? Is medium. It means we either downloaded medium or turbo. Well, it's possible it's turbo that we actually downloaded the last time. So it's not yet done downloading 2.8 gig. So large should give us really, really good results simply because it's a larger model. So let's see. It's even taking some time for it to do the inference because definitely we do need this TPU for large because without a TPU, sorry, without a GPU, probably a TPU would have done better or just as well. But without a GPU, no way. A large model like this cannot run on a CPU. It would take you like days to complete inference of this. So anyway, I'll let this run. While this is running, we can go back and look at the other part, which is speech to text. I'll let this run. I would like to come back and see, what it looks like, its own transcription, if it is much better or not. Okay. All right. So we've talked about speech to text. So now we'll talk about text to speech. Text to speech is the reverse of speech to text. So basically, it's technology that converts the written text into spoken audio using a computer generated voice. Right? It's also called speech synthesis and is used as an assistive technology for individuals with visual impairments or learning disabilities, or people who basically have speech disabilities or speech impairments. So what that means is you can communicate by typing stuff, and then the speech to text, or the text to speech rather, will read it out for your audience. So that's a common technology that's kind of becoming very popular these days, especially for people who are mute and people who cannot speak very well, or who have some kind of speech or learning disability. Um, but it's also useful for those who want to listen to content. So they cannot read, so but they can hear, obviously. So what they do is the content gets read out and it's easier to learn. It also is good for even, everybody in general. Like there are times you just don't want to read, you just want to listen, right? So you can take your novel or book and plug it into a text-to-speech app, and it reads it for you. And I wonder why we don't have more of such apps in the App Store, like Gobsmacked. I think there used to be Kindle or something, the Amazon Kindle. I don't know if it reads for you, but that's something that you can make for yourself. Because the fact that I've not seen a lot of them in the App Store probably means that there's no interest by a lot of people, but it's something I would be interested in, right? So, yeah. So it uses advanced AI to produce a natural sounding speech. One of the things you find out with text to speech is the better your model, the more natural sounding it is. The worse your model is, or the smaller your model is, the more robotic, the sound is. And of course, these days, if you go to YouTube and all of these, some of these pages, you see that a lot of people generate content simply by writing it and sending it. They don't even write it. They just ask one AI to generate it, and then they send it to a speech synthesis AI to, say it, and then they put it on a video stream. So these days, you can basically just build entire content without um, saying anything or doing anything. So how does it work? It converts text, natural speech, and the approaches that are used. We have what we call concatenative synthesis, which is an old method, right? Of basically every word had a way to be pronounced. Every word had a way to be pronounced. So if you have long sentences, you basically concatenate the pronunciation of each of those words to form longer words. That is easy to do, but the outcome is not very nice, because most times the way you pronounce a single word is not the same as the way you pronounce that same word in a sentence. The inflection changes, the intonation changes, right? The accent and the what do you call it now? The emphasis, changes. So the way you pronounce a word in a sentence, or at the end of a sentence, or at the beginning, or in the middle, or after a comma, or before a comma, it slightly differs depending on the word and where it is. So we now have the second one was a parametric synthesis, which is basically kind of an improvement over this concatenative synthesis using some kind of additional parameterization, but it's still kind of the old method. The state of the art now is neural network based text to speech, where you just have what we call it's a kind of end to end training. You give it the text and you give it the corresponding speech as training data, right? And it trains over a lot of this and it's able to generalize and generate its own speech, that matches what we have there. So you have OpenAI, the common ones. You have OpenAI text to speech V2. So just like Whisper, I don't think we would have access to that. Then we have the Azure Speech. Azure Speech is also an API. kind of. Then Google has WaveNet, and then Amazon Poly. I think the OpenAI TTS is an open model as well, just like Whisper, that you can download. So we'll see how we can make use of some of these. So what makes good TTS? There's what we call natural prosody, basically, you know, expression of the words, right? Emotion and expressiveness. Then low latency, right? Um, because it's important that if you're using it for a conversational real time, application, you don't want a situation where the AI or whatever is having long delays between when you say something and when it responds. Okay. Yeah. Then speaking of natural prosody and emotion and expressiveness, these days the expectations are so high that if you just it needs to sound natural, right? It needs to sound like it's an actual human being saying it, not a robot. And then it needs to be emotions embedded in the speech, and the right emotions. So that's something AI doesn't really get. It's not really getting very well still, right? Knowing the right emotion to embed at the right point in time. Okay, and then the expressiveness as well. Then, of course, we have support for multiple languages. I should be able to generate that speech in different languages. And you find that depending on the data set or the training of these models, they may be really good in one language, but not so good in others. And in most of the time, they are not really that good in African languages. So that's still another um, deficiency, which only Africans can actually solve that by training these models or, doing post-training or fine-tuning with African voices. Then, of course, you have custom voices and voice cloning. So there's a thing called voice cloning where you actually change the voice that the model is able to generate. So just like there's this thing called style transfer when you're talking about AI, you are separating what it is saying from the way it is saying it, right? And that's really what this is. Style transfer is actually in image generation, though. Yes, you are separating, the image that is generated from the style, you know, style. I don't know how much more I can say that, but in the context of voice or speech synthesis, it's also something like what I'm saying and the way I'm saying it, or the voice I'm using to say it, are actually two different things. And I should be able to kind of decouple the two so that the same model, I can tell it use a female voice or use a high-pitched female voice and all of that. It should be able to say the same thing with same inflections and all of that, but a different voice. And then, of course, the real-time streaming. So open TTS, and again, this is how you can access it, right? Um, um, you basically just call the client, you create the client, and you call client.audio.speech.create. And then you specify the model, you specify the voice. So like I said, so you have a voice that there are different voices which you can specify, and then you pass in the prompt that you want it to speak. Once it does that, you can then call the audio, uh, which will be an MP3 formatted audio, and then you can write it into a file. So of course, you will notice that all of this, we kind of have standardized on MP3 as the standard for the audio file that we're using for speech synthesis and recognition. So Azure also has this, so you can also get an Azure key, okay? And um, it Azure is enterprise grade. It provides a speech service. So it features both the text to speech and the speech to text, and then also real-time streaming and speaker recognition. Then it has custom voice training, which means it can allow you to train new voices um, and additional voices. And it's useful for large-scale production deployment. In other words, they have enough compute to handle large amounts of requests or traffic, on this. Remember, each time you have to do speech synthesis, there's a lot of computation going on. So um, that needs a lot of beefy hardware to be able to do that. So this is example of the codes that you would use for Azure speech. So you have Azure Cognitive Service speech, right? And then you configure it, specify which API key and region, and then you just call the synthesizer and you ask the synthesizer speak text asynchronous. And when it's done, you get that, and that's the result. So that's also a very simple way to do that. So this is also what you can do with Azure. You can analyze audio to determine categories, you know, like music genre, call center compliance, gunshot detection, scene environment monitoring, emotion detection. We've talked about things like this. And Azure typically uses CNN or transformers over spectrograms. Spectrograms are kind of the older way of doing it, right? Then, yeah, this is how you would do an audio classification with an Azure TTS. You load the audio, you convert it to mel spectrogram, you feed into the model, right? Then the model will give you an output, which you can then use softmax, and then you label probabilities. And then you can do post-processing with that. So we can talk about that. Then this is also if you want to um, do classification. Okay, that's the same thing. This is the code for it. This is kind of basically the code for it. This is how you start. So you start with waveform, touch audio.load. So you load the sound file that you want to do the classification, which is the step one. And then you do the transforms mel spectrogram, which will convert to mel spectrogram. And then you apply that transform to it. Then after that, you do the inference, which you can then take this mel is kind of, think of this mel as a kind of embedding, equivalent of an embedding in the context of sound, which you can then pass into whatever model that you have built that will do classification for you, and it does the classification, right? So then we have audio transcription pipelines. So for audio transcription, the basic workflow is upload the audio, then you run speech to text, which is either Whisper or Assembly AI or any other one that you can get, Gemini and so on. Then you extract metadata based on the transcription prompt that you give, right? So you can or rather based on the prompt plus the result of the transcription that you have gotten from the speech to text. And then based on that prompt, you can ask for topics, for sentiments, and then this extraction of metadata, you can use a model or you can run some heuristic on it, right? Or run some code that will do that. And then you can summarize using LLM. The other thing is for Assembly AI can actually give you metadata. After running the speech to text, it can give you metadata that you extract. So you don't need to do a separate run for that. Whisper may not be able to give you metadata, but I think we'll check it again. You'll see that there's still some little metadata that Whisper gives to you. So you take the text, maybe you bring the metadata along as context, and you pass that into a large language model, a conversational large language model, and ask it to do a summary. And then you can take that summary, right, and store it. either in a database, maybe even a vector database with embedding so that it's easy for you to pull out the results, or you send it in an email or display. So this is like a simple workflow if you wanted to create audio transcription, similar to what we are seeing in all of these apps. So what that means is that effectively you can also do your own audio transcription application. So these are some of the real world applications. You can have meeting assistants like we talked about, podcasts, indexing, customer support QA, right? Healthcare dictation, or any kind of dictation for that matter, right? Then voice bots and call summarization, legal disposition and transcription. I also mentioned a banking app, that uses voice banking. So remember, we did a prompt chain that we use banking, but we just did a prompt chain. So imagine now you can plug in your speech to text, so the client can even just talk to your bot, to your app, and ask those same questions. You convert them to text. So that will be the first step. Then you pass it into that your prompt chain. And then the response that comes, um, you can then push it out through another text to speech that will synthesize voice and then send it back. So you end up building a really nice conversational help application. Okay, so let's see what we can do. Yeah, so this is done now, which is, I'd like to see what this version of our, this is the one that, this is Whisper Large. Let's see how well it did. It's Friday. Good morning. Welcome to Excel News 360. Here are stories and events making rounds. As STEM school, so it's still making that mistake here. Back and 6-week holiday. Yeah, so STEM schools are back, and so this whole thing is wrong. As STEM schools are back, but I guess it has to do with the training data. Gemini got that very well. STEM schools are back, right? Even though schools has an apostrophe. So, but this is still wrong ends. But it's interesting for me that it couldn't tell that this is Excel News 360. Rather, it says for the 60. So for me, I think a key takeaway with this is if I wanted to build a really robust system, I would probably use like two models. Okay. And well, that might be too expensive, but at least I would take the outcome from the speech synthesis and still pass it through an LLM and ask it to clean it up. But maybe better to take the output from two models, and I would ask a third LLM, look at these two, outputs, and, blend the two of them together and give out the most likely correct output. And I'll take that from the LLM and then use it to do whatever I want to do. So, for me, one of the key takeaways in this whole exercise is the speech synthesis and speech recognition, they're not perfect, right? So that is one thing you need to take note of. Now let's see if I can do text to speech. So I'll close with text to speech. Yeah, I don't know about assembly AI. I have not tried it. So I would ask everyone to go try and see what can we, but from what has been said already, assembly AI is much better. So I think I'd like to try that, but I'll do that after doing text to speech. So let me do text to speech, and I need to find if I can do text to speech with Gemini. So let's start with that. Let's start with that. I want to do text to speech with Gemini first. So we would still use the same model that we are using, right? Um, okay, so let's set everything up. So I start off by importing Google.generative AI as Gen AI. By the way, one of the things I learned in this is if you're not using the runtime, it's good to shut it down. So I kind of got ran out, or I kind of used up my TPU allocation because I left it running overnight and I forgot to shut it down. So right now I'm going to just disconnect and delete, so that because accounting I have an allocation. I think everybody has that. So I don't want to run it out anymore, so that I can use it for something else. So for now, I'm just going to try Gemini on a CPU. I'm not going to do this with a TPU. I'm just going to, so it's still running on a CPU. Okay. So I need to do another import, text to speech. So interestingly, what most people don't understand is that Python even has a built-in text to speech, which I'm going to demo, right? And um, iOS, right? iOS and Android have built-in text to speech, which those who are writing Flutter code, you should be able to leverage it as much as possible. In other words, the phones themselves. But you notice that the text to speech on the phones, both iOS, Android, and other phone operating systems, they tend to get better when you have good connectivity, because when you have good connectivity, they actually call out to the bigger models in the backend. But um, when they are not, right, they don't. When they are not connected, they use the smaller edge model that are on the device. So you find that the quality of speech generation or transcription falls when you don't have network connectivity. That's something that I identify. But these days, that was in in those times of old. But these days, I found that um, the we have better edge models, that are more capable, even though it's still the same size, right? But they are more capable. So I'm importing text to speech, which is a library from Google Cloud. Then we will just initialize the client, text to speech dot um, text to speech client. Okay. Then we can just ask it to synthesize input, right? Synthesize the speech. Okay. text to speech. A test message. Yeah. Okay. Need to import first. Okay, this is um so for Gemini, you actually have to first of all go to your Google console. So let me show you how to do this. Um it's a bit of an involved process. And then you have to set up text to speech here. This is an involved process. So I might actually have to um yeah, this is an involved process. So let me skip this for now and just show us how we do with the with OpenAI. Again, the same thing you would need to have. So let's try Assembly AI and see if we can do that with Assembly AI. So for Assembly AI, um, you have to, as usual, you have to create an account and get an API key. So let's do that. I'm going to do that in the background. Yeah, I usually like to just use my email to create rather than um, linking it to my account. So when you put in your email, um, you're going to get a token or yeah, a token sent to your email. So you can log in. You can either click the link or okay, it's a link. It's not actually a token. So I'm going to open the link. I'm going to open my email and I'll click on that link. So this is typically how the email looks like. Basically, it says click on this button to log in. So we click on the button. All right. So I now have to read their terms and policy. By the way, when it comes to reading terms and policy, they're so long and boring. So sometimes I used to wish in those days I had a bot that could read terms and conditions and, you know, just tell me whether I should agree or not. Of course, we have all of that here now. So these days, what I just do is I I send the link. If it's an open link, I send the link to any of these large language models and tell them, okay, hey, look at this policy and tell me, is there anything I should be worried about? So I always encourage people to read the terms. Don't just don't just click and say yes, I agree. Read the terms. But if you don't have time to read, send it to an LLM and ask it to read it and summarize for you, and then you can read the summary. Okay, so I got an API key. So let's use that now. I'm going to use that to create a new. I'm going to create a new collab and use Assembly AI. So it does look like Assembly AI has a lot of um, let's see, dashboard. I'm assuming there's a dashboard. Yeah, there is. Okay. So they gave me $50 worth of free credits, which is cool. And I can do stuff with it. I can test models with audio, with my audio files. I can actually upload models here and see how it does. But I also like to know how I can code it. So I go to the code and you have Python, you have JavaScript SDK as well. You have another Python where you can do an API call. This is API based call. All right. Just using requests. Um, this is JavaScript also using API with Axios. So you can just do an API call. There's a PHP endpoint as well. I'm sure this also uses endpoints, API call. You have Ruby, you have C Sharp. So you can either do any of this, right? So let's see. I can go to Python and let's start with first of all transcribing MP3. So Assembly AI. I'm going to name this Assembly AI voice. Okay. So in order not to waste too much time, I'm just going to copy their code and post it. And okay, here's the API key they gave to me, which I guess that should be it, right? So the audio file is not in the. So what this tells you is you can also download audio files straight up from the net, right? But here the audio file is just right there. I will upload the same file that we had and I'll name it audio.mp3. Okay, so let me upload the file again. Okay, so I'm going to rename it to audio mp3. I don't need to put a .m file in this case because I already have this. Okay. So you import assembly AI. So I guess I have to install assembly AI with pip, which is what this said. You have to pip install first, pip install assembly AI. So I'm going to do that here in a code block, running a command pip install assembly AI. Yeah. Okay, so that's going to install. So what else will we be looking at? So it's installed already. Then so you have AAI, which is assembly AI transcription configuration. We specify speech models is universal, and then we call a transcriber. We pass in the configuration, and then we create transcriber rather, and we pass in configuration, and then we call transcribe on that transcriber we just created. We pass in the audio file, and then if there's any issue, you check if there's an error, and if there is, then you can throw an exception. All right, so this is for speech to text, right? So you can see it looks pretty good. Let me see how good it is. You are listening to the news live on XLFM. It's Friday. So it got the XLFM, it got the news. Oh, it didn't get this. This is still 3060, 360. Here are stories and events. Esteem schools. It did get the Esteem school, so this is nice. So it's better than Whisper. Ah, our back and but this is still not correct. Our back is still not correct. And end 6 week holiday. Anyway, this is really more about the accent, right? Um, okay, so we are able to use Assembly AI to do um the pre-recorded audio. We can also do streaming audio. So I think I'll advise you to go and check out streaming audio is where it's not a file that you are uploading, right? File is pre-recorded, but it is speech that you are picking up continuously and sending it. So you need to be able to set up a streaming or an audio stream. And in most cases, if you do an audio stream, you have to connect it to a microphone. So that's something I was hoping I'll have enough time to do it here, but I don't. So you can go do some research on that. How do you grab the microphone from a device and then continue to pick up the microphone audio stream, and then you can send it as a streaming um you know payload. Yeah, okay, there it is. This is a good example of how you can do this, right? So you have what we call a microphone stream. So just by calling microphone stream, it's going to grab um your microphone. It's going to ask for the permission to use your microphone, and then it's going to grab it and it's going to pull that data. Okay. So I want to do text to speech. So yes, Ginika, go ahead with your question. Or maybe the question has been answered already. Yes, go ahead. Go see.
I wanted to ask on the microphone one, would that work if you're mobile or if you're on a browser or something like how is that controlled?
Yeah, well, that depends on the environment, right? Um, so the main thing is there should be an API documentation that you can check that allows you, tells you how you can connect the microphone. If it is on mobile, it's easy because on mobile you just ask for permission, right, to use the microphone. And then you can then grab the microphone stream will be available either as a function or an instance of a class that you create, and then you can be picking the data from it as a stream. So you take that stream and you plug it in. I need to find examples that we can show. But yeah, for Python, oh, by the way, I even mentioned I'll talk about Python has text to speech as well, a TTS library, which I'll try. It's not as good as the LLMs, right? But it's still good because I've tried it. Um, I've tried it as well, and it was giving me some really good. The only thing is you're going to record the speech for you, and you would have to find it, right? So, but to answer your question, yes, you have to look at depending on the environment. There's a standard way of getting the microphone and getting the microphone stream. Like you can see here, even though the microphone stream here is actually a class in the Assembly AI SDK. So, but they've just made it so it's easy for you to easily um, connect. Let's look at JavaScript, and I can show you. For JavaScript, you have look at how they do it in JavaScript. You have recorder. You are going to get an instance of the recorder, right? So recorder is basically gotten from this node record LPC M16 library, which allows the Node.js to access your whatever device that acts as a recorder, which will be a microphone. Okay, so you get the recorder and you have the transcriber which you have set up, and it's a streaming transcriber from the Assembly AI client. Then you have events, management here on open, on error, on close, then on turn. So this is transcriber on turn, basically meaning, you know, I don't know, on turn, if not on the transcript. Okay. So you connect this, you connect the transcriber, and then you start recording. So this recorder remember, it's a Node.js library. So you basically start recording, and then you specify the audio type that you are recording, the channels, and the sample rate. So the recorder is going to record from a microphone. And as it is recording, you are maintaining a handle or a reference to the recording, which could be a stream. And then you um you use readable to web. Basically, you take so this is just a way of taking the recording, right? And piping it into the transcriber stream. So the recording has a stream and the transcriber has a stream. So you connect the two of them together using this function, readable.toWeb. And readable is a class that comes with Node.js, a stream management class. Basically, it allows you to manage multiple streams. So one of the things you can do is you connect two streams together. So a stream is like a pipe. So when you connect two streams together, that means any information that comes into the first stream and goes out will directly go into the next stream that you connect it to, right? So what is happening here is when you do that, once recording starts, information begins to flow into the recorder, the stream from the recorder, and that same information will flow from there into the stream of the transcriber, which is the the assembly AI transcriber stream, that you have created. So a stream is data that is continuous, right? And it doesn't end. So basically the way streams are treated is that the transcription will happen on the fly. It won't wait until all the data has arrived. They need to now close the stream or close the connection and then try to transcribe it and send you a response. No. And that's one of the things we didn't go a lot into streaming data. So maybe we may look at that, because when it comes to all of these AI and LLMs, there's a lot of streaming involved, especially when when context windows begin to become large, or you are dealing with large data, like you're uploading files, or like in this case where you're recording from a microphone. It's streaming across. It's real time as it is streaming across. At the other end, the endpoint, the LLM receives it, right? The assembly I receives it and sends that. It doesn't wait until it's all completed. It just sends the chunks. Essentially, it's chunking things, right? So it sends those chunks into the LLM. But at times, it may actually wait until the stream is, completed. Maybe like if it is speech, when there is a pause. So that's the logical time to say, okay, let's chunk all of this together and then sends that to the LLM. The LLM does the transcription and will send it back to you also as a stream. So yeah, so this is basically how this works. Okay. Um, so I want to try two things before we end. The first is we've not done text to speech yet. So I want to do text to speech, but with assembly AI, and then I want to do text to speech with, you know, basic Python, right? And basic Python, I can do both the text to speech and speech to text. So it's something I would like to try. Okay, so let's see. So let's do text to speech with um okay, so assembly AI, um let's do text to speech with let's see. I don't think assembly AI does text to speech. So let's do with okay, so okay, it's OpenAI that does text to speech and Azure. We can also try Azure. There's also a basic text to speech with Python. So let's try that. So to do that, we have to install TTS. I'm surprised it's TTS with uppercase. ITTS X3. Yeah, I got the wrong. I didn't get the right um, module. So you do PyTTS X3, uh, then now what? Yeah, let's run this. So we imported PyTTS X3. So PyTTS X3 basically runs outside of um, it can run without internet connection because it basically has libraries that it needs, to do the speech to text. If you want to do a simple speech, text to speech rather, you would just do PyTTS X3. That's basically Python text to speech X3, right? And then you specify what you want to say. So it's supposed to generate an audio file, text to speech. So this is like the simplest way you do this. Okay, so that's the other thing. You need to have there are some requirements which need to be installed in order for us to have it run. Okay, so you would have to install either eSpeak or AV Speech, right? So let's see. I'm going to install eSpeech. Now the interesting thing is that eSpeak actually exists on Linux, Windows, Android. It probably will not be on this VPS because, but let's see if I can install it and make it install, make it speak and store it as, it's going to store it as a wave file, which we will try to read. So these are kind of, um, these are libraries that have been there for a long time. So, okay, so this requires us to install it on the, let me run the installation. It requires us to install, yeah. So, um, I can specify the ng. Ng is like next generation, right? eSpeak is the new is so you have eSpeak, which is the old one, and then you have NG, which is the next generation, like the new one. Then install eSpeak, install lib eSpeak, and um Python 3 dev. So we want to install this. So this is how we install libraries on Linux. You can also do the same thing if it's a Windows, then you have to figure out how to install it. But you can go to eSpeak to find out how to do that. It seems I misspelled something. Lib eSpeak -ng -dev. Okay. So you have to make sure eSpeak is installed because the Python TTS depends on it. Okay, so this has been installed. So now I think we should be good to go. Right. Um, so I have eSpeak installed, but okay. Let's try the older one. Okay. Update. Hmm. Let's run update. Update takes a long time. Okay. Apt sudo apt install eSpeak. Let me even just kind of skip the dev first and see if this works. Okay. Now let's do this. Um, okay, let's add the dev um, eSpeak. Um, ispeak, lib ispeak, lib ispeak, dev, and then Python. I assume Python dev is already installed. Okay. Okay. Now it's possible I missed another import. I need to pip install the Python binding for it. Espeak Python. Okay, espeak ng Python. Yeah. So I basically have to do the next gen. Let me do the next gen. Okay, well, um, let's 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 try something else. So the PyTTS X3 is using eSpeak, and I am probably missing the voice. There's a configuration that I'm missing. So set voice by name. Now with eSpeak, you could actually just run eSpeak directly. For example, um, okay, um, I need to install the eSpeak sudo apt install eSpeak ng and leave eSpeak ng dev. I've already installed the Python 3 dev. Okay, so this one works. Then I can install the Python eSpeak ng Python, and that was successful. So you need to install ng is a new way of doing it, I guess. So I'm going to redo this so that it's clear what I just did. With eSpeak ng, I don't need TTSX anymore, so I can just directly use eSpeak ng. Right. eSpeak ng, eSpeak underscore ng. So this is, we have eSpeak ng on GitHub. So I would like, if you're a Python dev, go and check it out. Okay. So anyway, I have eSpeak now. I have eSpeak ng. Let me see. if PyTTSX3 is still going to give me the error. So we still have this error, which set voice by name, which there is no, maybe there's a configuration I need to do. So let's try this. A second approach we can try for this. So here's the second approach. I need to troubleshoot why this one is not working. But here's a second approach. So in this approach, we are just going to call to the engine, right? And um, we'll create an engine and initialize. Okay, then we'll have the text. We can do engine.say. Hello. This is a test of Python text to speech. And we can now do engine.run or run and wait. And then engine.stop. Okay, so we have the same problem here. Basically, this means it cannot set the voice. So this might be because I am running in a Jupyter environment. If I'm running on my local Python, this should work. So I will, let's see if I can do that. Let me see how fast I can do that in a Python environment. Okay. Uh, okay, I'm going to set up a VPS. I'm going to just I'm going to go into a VPS. So let me try this on a VPS. Okay. Well, because we've run out of time, I don't want to extend this any longer. So I would let's try it out both on the mobile. On mobile, it's actually easy to do text to speech, speech to text because all the libraries are installed. But here, on a server, it's typically difficult because you kind of have to install drivers and all kinds of things, right? That's probably why this is failing because I'm basically running it on a server side. So, but I will share with us how you would do it with a mobile. If you're doing it for a mobile app, for example, or you're doing it with JavaScript on a browser. where all of the drivers are installed. But here you basically have to install all the drivers. And I think even at that, the reason for this not working is this device, even though we've installed the drivers, it most likely it doesn't have a microphone. It doesn't have any codec for recording, even though I should be able to configure it to just record, right? Instead of trying to speak it. So because there's no driver for sound, that is why I believe it's failing. But we can make it record, right? And if we make it record, then we can download the recorded sound and use it. So that's another approach. If you are doing it on the server side, in most cases, that's what you would do anyway, if you are, doing it. So, yeah, that's it for, for speech. When we come on Friday, we are going to look at the image, and then we'll pull everything together in multimodal. But for with this, you can actually build an end-to-end speech-driven app. Okay, so let me end it at this point.